Welcome to Between Sleep and Science tonight. We turn our attention to a celestial phenomenon that has held the human imagination captive since the first eyes looked upward into the primordial dark, the falling star. These brilliant, silver-white streaks cutting across the velvet sky are among the most enchanting sights in the heavens. They are transient, mysterious, and impossibly elegant, silent pulses of poetry written across the firmament. Before we begin our exploration of these cosmic wanderers, I invite you to settle into a space of absolute comfort. Let your breathing find its natural, slow rhythm. There is nothing you need to do now except listen and wonder. Allow the story of the stars to carry you toward a state of deep, restorative rest. Despite the name we have given them for centuries, a falling star is not a star at all. It is a beautiful, celestial deception. In reality, the stars we see, the fixed points of light in constellations, are gargantuan suns. They are massive, roaring engines of nuclear fusion, anchored in place across light years of void. What we witness streaking above us is something much closer, much smaller, and far more intimate. What you are actually seeing is a fragment of space itself, a piece of rock or metal, often no larger than a tiny grain of sand, making its final dramatic crossing into our world. When we see that sudden flash, we are watching a traveler that may have drifted in the silent, frozen vacuum of the solar system for millions or even billions of years. It has finally met the embrace of Earth, the science of the glow, not fire but speed. As these microscopic travelers slam into the invisible blanket of air surrounding our planet, they aren't burning in the way a candle does. They are glowing because of sheer unimaginable velocity. A meteoroid enters Earth's atmosphere at staggering speeds, ranging from 11 kilometers per second to as much as 70 kilometers per second. To visualize this, consider that a bullet from a high-powered rifle moves at about 1 kilometer per second. These cosmic grains are moving 70 times faster. At such speeds, the air itself becomes a solid barrier. Even in the thin upper reaches of the atmosphere, the meteoroid hits a wall of oxygen and nitrogen molecules. It compresses the air in front of it so violently that the temperature skyrockets to thousands of degrees in a fraction of a second. This intense heat causes the surface of the rock to melt and vaporize, creating a glowing trail of superheated gas, a plasma, that we perceive from the ground as a streak of light. The final goodbye. What we admire as a shooting star is, in truth, the final moment of a cosmic journey. Most of these fragments never reach the soil. They are completely consumed by the intensity of their descent, transformed from solid matter into pure light. The trail left behind is a final goodbye from a piece of debris that has existed since the dawn of the sun, now becoming one with the atoms of our atmosphere. Ancient perspectives and the divine connection. Long before we had the tools of modern physics, the ancient Greeks described these lights as planetae, the wanderers. They could not calculate the friction of the mesosphere, but they recognized the profound mystery of the sight. To the ancients, a falling star was a crack in the celestial sphere, a moment of direct connection with the divine. It was often interpreted as a sign from the gods, a celestial omen of things to come, or perhaps a soul transitioning between worlds. Even today, in our era of high-resolution telescopes and deep space probes, that sense of magic remains. We still pause mid-sentence to point them out. We still close our eyes and whisper wishes upon them. There is a deep human instinct to feel that for just a second we have witnessed something truly miraculous. When you watch a meteor shower, you may notice that not all streaks are created equal. Some flash with a brilliant, sterile white, while others leave a haunting trail of emerald green or a warm, glowing orange. These colors are not random accidents of the night. They are a celestial chemistry report broadcast from miles above the Earth. The color of a meteor is dictated by two factors: the speed of its entry and the chemical composition of the meteoroid itself. Most often, you will see white or yellow. This is the result of the sheer heat generated by iron, a common element in space rocks, and the excitement of the nitrogen and oxygen in our own atmosphere. But occasionally, the universe treats us to a more vivid display. A meteor that flashes with a distinct green tint reveals the presence of nickel or copper. These elements, as they vaporize in the atmospheric furnace, emit light at specific wavelengths that our eyes perceive as a shimmering emerald. Orange or yellow trails are often the signature of sodium, while the rarest and most striking colors, blue and violet, usually indicate the presence of magnesium or calcium. Each falling star is a unique chemical event, a brief and beautiful laboratory experiment performed in the open sky. The triple identity: meteoroid, meteor, and meteorite. To the uninitiated, the terminology of space rocks can seem like a confusing maze. However, there is a simple and elegant logic to it, defined entirely by the object's location. 1. The meteoroid. While a fragment is still drifting through the silent, airless void of space, perhaps orbiting the sun for eons, it is known as a meteoroid. It is a traveler without a destination, a silent ghost of the early solar system. 2. The meteor. The moment the traveler crosses the threshold of our atmosphere and begins to glow, it earns the title of meteor. This term refers specifically to the phenomenon of light, the streak itself, rather than the rock. It is the event, the shooting star we see with our eyes. 3. The meteorite. On the very rare occasion that the object is large enough and sturdy enough to survive its fiery baptism and actually touch the ground, it receives its final name, meteorite. These meteorites are among the rarest treasures on Earth. To hold one is to hold a piece of the cosmos that has survived a journey of millions of miles and a descent through thousands of degrees of heat. The cosmic harvest. 100 tons a day. It is a staggering thought, but our planet is constantly growing. Every single day, scientists estimate that Earth sweeps up approximately 100 tons of meteoritic material. If this sounds like a frightening amount, there is no need for alarm. The vast majority of this cosmic rain arrives in the form of microscopic dust, particles so small and light that they drift through the atmosphere like smoke, settling on the ground without ever creating a flash of light. You have likely walked past or even touched this stardust without ever knowing it. The meteors we see, the ones that capture our attention and make us gasp, are the exceptions. They are the fragments large enough to announce their arrival with brilliance. Most of these visible travelers never make it to the surface. They give everything they have in those few seconds of glory, disappearing into atoms and becoming part of the air we breathe. Ancient luck and modern wonder. Even though we now understand the physics of atmospheric entry and the chemistry of plasma trails, the ancient wonder remains unchanged. For thousands of years, humans have interpreted these events as symbols of luck. In many cultures, the falling star was seen as a blessing, a moment where the veil between the heavens and the earth was at its thinnest. This tradition persists in our modern world through the simple act of making a wish. There is something deeply human about connecting our personal hopes to a grain of sand burning 80 kilometers above our heads. It reminds us that we are part of a larger story, a story of a planet moving through a vast, debris-filled ocean of history. To the casual observer, the space between the planets might seem like a perfect hollow vacuum, a vast nothingness where silence reigns supreme. But this is another of the cosmos's many illusions. In reality, our solar system is a crowded, busy place, filled with the scattered architectural debris of a world-building project that began 4.5 billion years ago. Between the orbits of the planets lie countless trillions of fragments, rock, metal, and ice. Some are the size of mountain ranges, others no larger than a speck of soot. These are the source materials for every meteor that has ever graced our sky. They are the leftovers of the early solar nebula, the material that never quite found its way into becoming a planet like Earth or a giant like Jupiter. Comets, the icy guardians of the outer rim. The most prolific authors of our meteor displays are the comets, often described by astronomers as dirty snowballs. A comet is a fragile mixture of frozen gases, such as water, ammonia, and methane, interwoven with dust and primitive rock. Most of these icy wanderers spend their lives in the cold, dark reaches of the outer solar system, in regions like the Kuiper Belt or the Oort cloud, far beyond the warmth of our sun. But occasionally, a gravitational nudge from a passing star or a distant planet sends one of these icy mountains on a long, elliptical journey toward the center of the solar system. As a comet nears the sun, a magnificent transformation begins. The sun's intense radiation starts to heat the comet's surface. Because there is no liquid phase in a vacuum, the ice undergoes sublimation. It turns directly into gas. This escaping gas acts like a cosmic jet, blasting outward from the nucleus and carrying with it the dust and pebbles that were once trapped inside the ice. This liberated material forms the comet's iconic tail, a glowing veil that can stretch for millions of miles. But while the tail is what we see from Earth, the comet is doing something far more enduring. It is leaving a trail of breadcrumbs behind it. The rivers of debris. Imagine a comet as it orbits the sun. It doesn't just pass through space, it sheds its weight. It leaves behind a massive, invisible river of dust and pebbles that follows its orbital path like a ghostly shadow. Over thousands of years and many orbits, this debris spreads out, creating a broad, continuous stream of matter that can span billions of miles in length and hundreds of thousands of miles in width. These are the debris streams, brie. They are rivers of silence, floating in the dark. And this is where Earth enters the story. Our planet travels along its own fixed orbital track around the Sun at a speed of nearly 30 kilometers per second. Every year, at the exact same points in our orbit, we encounter these rivers of dust. The cosmic collision, the mechanics of a shower. When Earth's orbit intersects with one of these debris streams, we pass through it like a ship cutting through a thick bank of fog. Only in this case, The fog consists of millions of tiny particles hitting our upper atmosphere simultaneously. This is what creates a meteor shower. This explains the remarkable regularity of the heavens. We know, for example, that every mid-August we will see the Perseids. We know this because that is when Earth arrives at the specific intersection point with the debris left behind by Comet Swift-Tuttle. It is a celestial appointment that has been kept for millennia. If the debris stream is young and dense, the resulting shower can be spectacular, a flurry of hundreds of lights per hour. If the stream is old and the particles have begun to drift apart, the shower may be more subtle, a gentle reminder of a comet that passed by long ago. The lone wanderers, sporadic meteors. Not every falling star is part of an organized shower. On any clear night, regardless of the date, you can see random meteors. These are known as sporadic meteors. They represent the general background noise of the solar system. These wanderers might be fragments of asteroids that collided in the belt between Mars and Jupiter millions of years ago. Or they could be dust from comets that have long since vanished from existence, their icy cores completely evaporated. They are the orphans of the cosmos, fragments without a home, drifting through the dark until they meet their end in the brilliant flash of Earth's atmosphere. The perspective of perspective. When we watch a shower, the meteors seem to fan out from a single point in the sky, which astronomers call the radiant. This is an effect of perspective, similar to the way parallel railroad tracks seem to converge at a single point on the horizon. The meteors are actually moving in parallel lines as they hit Earth, but because we are looking up the tracks of their motion, they appear to emerge from a central source. This radiant point is how we name the showers. If the meteors seem to come from the direction of the constellation Perseus, we call them the Perseids. If they appear to emerge from Gemini, they are the Geminids. It is a system that allows us to map the chaos of space onto the familiar patterns of our stars. If you were to look at our planet from the cold, airless perspective of deep space, you would see a fragile blue marble protected by a thin, shimmering veil of gas. This is our atmosphere. It is the only thing standing between the delicate life on Earth and a constant, lethal bombardment from the cosmos. Without this gaseous envelope, our world would be a desolate, cratered wasteland, indistinguishable from the scarred surface of the moon. The atmosphere is not just the air we breathe. It is our primary planetary defense system. Every hour of every day, it acts as both a destroyer and a revealer. It systematically incinerates trillions of incoming objects before they can ever touch the ground. To understand a falling star, we must first understand the structure of this invisible fortress. The architecture of the air. Our atmosphere is not a uniform block of gas. It is a complex, layered structure, like a blanket with many folds, each with its own unique characteristics. The troposphere. This is the bottom layer where we live, where weather happens and where the air is densest. The stratosphere. Above the clouds, home to the ozone layer. The mesosphere. This is the critical zone. Located between 80 and 120 kilometers above the surface, this is the laboratory of the falling star. Here, the air is thin enough to allow for incredible speed, but just dense enough to create the resistance needed to ignite a meteor. The thermosphere. The uppermost reaches, extending hundreds of kilometers into the edge of the void. The hypersonic collision, from vacuum to furnace. Imagine a meteoroid's journey. For millions of years, it has existed in the absolute silence of a vacuum, where temperatures hover near absolute zero. It is cold, dark, and still. Then, in the blink of an eye, it encounters Earth. When the meteoroid hits the upper reaches of the atmosphere, it is traveling at hypersonic speeds, up to 70 kilometers per second. At this velocity, the air molecules do not have time to move out of the way. Instead of flowing around the rock, they are violently compressed in front of it. This is a process known as adiabatic compression. Think of a bicycle pump getting warm as you use it. Now, imagine that effect magnified 1,000,000 times. The air in front of the meteoroid becomes a superheated wall of plasma, reaching temperatures of thousands of degrees Celsius. This is the moment of ignition. The cold, dark rock from space is suddenly transformed into a brilliant, incandescent spear of light. The art of ablation. As the heat intensifies, the surface of the meteoroid cannot hold itself together. It begins to melt, then boil, and finally vaporize. This process is scientifically known as ablation. From the meteoroid's perspective, if we can imagine it having one, the experience is one of total, violent disintegration. Layers of stone or metal are stripped away in microseconds, blown backward to create a long, glowing tail of ionized gas. This trail can be many miles long, even though the object creating it might be no larger than a pebble. It is a profound paradox. What we perceive from our backyard as a moment of serene, graceful beauty is, in reality, an event of total annihilation. The meteoroid is giving up its physical form, sacrificing its billions of years of existence to create a few seconds of light. The silence of the heavens. One of the most haunting aspects of watching a falling star is the absolute silence. We see a brilliant flash, an event that we know involves immense energy and atmospheric upheaval, yet we hear nothing. There are two reasons for this. First, light travels at 300,000 kilometers per second, while sound is a relative crawler, moving at only 340 meters per second. By the time the sound of a meteor's passage could reach your ears, the light has been gone for several minutes. Second, because meteors occur in the mesosphere where the air is extremely thin, there isn't enough medium to carry a loud sound wave effectively to the ground. Most falling stars are ghosts. They appear, they dazzle, and they vanish without a whisper, leaving the silence of the night undisturbed. The atmospheric filter. This shield is also a filter. Only the strongest and largest objects survive. A grain of sand might blaze brilliantly for half a second before it is entirely consumed. A pebble might last 2 seconds. Only objects the size of a fist or larger have any hope of reaching the lower, denser layers of the atmosphere. By the time the remains of a meteoroid reach the troposphere, the air we breathe, they have usually lost 90% or more of their original mass. The atmosphere has digested the cosmic visitor, turning its bulk into light, heat, and a fine rain of microscopic dust that slowly settles to the Earth. In the normal course of a year, we experience meteor showers, predictable, gentle displays where a patient observer might see 20 or 60 streaks of light in an hour. These are the regular appointments our planet keeps with the dust of ancient comets. But on rare, extraordinary occasions, the universe offers something far more intense: a meteor storm. A meteor storm occurs when Earth passes not just through the edge of a debris stream, but through its thickest, most concentrated heart. In these moments, the frequency of meteors leaps from dozens per hour to thousands per minute. The sky is no longer a dark canvas with occasional flashes. It becomes a theatre of cascading fire, where the very fabric of the night seems to be unravelling in a torrent of light. The Leonids, the sovereigns of the storm. If there is one name that strikes awe into the hearts of astronomers, it is the Leonids. This meteor shower, which occurs every November, is associated with Comet Tempel-Tuttle. Usually the Leonids are modest, but roughly every 33 years they explode into a spectacle that defies description. The most famous of these occurred on the night of November 12th, 1833. This event was a pivotal moment in human history. Across North America, people woke to find the sky in flames. Witnesses described meteors falling as thickly as snowflakes in a winter blizzard. Some estimates suggest that over 100,000 meteors per hour streaked across the firmament. For many who witnessed it, the 1833 storm was a source of pure terror. Without a scientific explanation, many believed the world was ending, that the stars were literally being swept from the sky. People fell to their knees in prayer, convinced they were witnessing the final moments of Earth. Yet, for the scientific community, this terror was the catalyst for a revolution. The night science looked up. Before 1833, most scientists agreed with Aristotle, believing that meteors were an atmospheric phenomenon, basically hot air or exhalations from the Earth that ignited in the sky. They were seen as weather, not astronomy. But during the Leonid storm, observers noticed something crucial. All the meteors, no matter where they appeared, seemed to fan out from a single point in the constellation Leo. This was the discovery of the radiant. Scientists realized that if the meteors were coming from a specific point in space, they must be extraterrestrial. They weren't weather at all. They were cosmic debris. This single night of falling stars birthed the modern science of meteoritics. The Perseids, summer's reliable gift. While the Leonids provide the rare historic storms, the Perseids are the reliable companions of the human experience. Every August, Earth encounters the debris of Comet Swift-Tuttle, a massive icy body nearly 26 kilometers wide. Because the Perseids arrive during the warm nights of the Northern Hemisphere's summer, they are the most watched of all showers. In medieval Europe, they were known as the Tears of St. Lawrence, named for the martyr whose feast day falls on August 10th. Legend said the sparks from the saint's fire were being transformed into golden streaks in the sky. The Perseids are famous for their fireballs, extraordinarily bright meteors that can outshine even the planet Jupiter. These fireballs occur because Swift-Tuttle's debris is often larger and more solid than that of other comets. When these cosmic pebbles hit the atmosphere, they don't just flash. They explode with a brilliance that can cast shadows on the ground below. The Geminids, the outlier of December. As the year draws to a close, we encounter the Geminids. This shower is a scientific mystery. Unlike almost every other major shower, the Geminids do not come from a comet. Instead, their parent is an object called 3200 Phaethon. Phaethon is classified as an asteroid, but it behaves in ways that baffle astronomers. It follows an orbit that brings it closer to the Sun than any other named asteroid, heating its rocky surface to over 700 degrees Celsius. Scientists believe this extreme heat causes the rock to crack and crumble, shedding dust like a comet would shed ice. The Geminids are unique because they are slow meteors. They hit the atmosphere at about 35 kilometers per second, half the speed of the Leonids. This lower velocity, combined with their rocky composition, allows them to last longer in the sky, creating graceful, glowing arcs that often show hints of yellow or even blue light. The rhythms of the cosmos. Watching a meteor storm or a heavy shower is a lesson in the immense scale of time. The dust we see burning tonight may have been shed by a comet during the time of the Roman Empire, or even earlier. It has been orbiting the Sun in total silence for 2,000 years, waiting for this exact moment to meet the Earth's atmosphere. When you lie back and watch these storms, you are not just seeing light, you are seeing the clockwork of the solar system. You are seeing the remnants of ancient travelers, the ghosts of comets, and the protective embrace of our atmosphere, all working together in a display that is as violent as it is beautiful. When you look at a shooting star, you are witnessing an act of total consumption. Most cosmic fragments enter our atmosphere as fragile dust or porous rock, and they vanish as light. But a tiny, resilient fraction, perhaps less than 1%, manages to beat the odds. These are the survivors. To survive a journey that begins in the frozen absolute zero of space and ends in a hypersonic collision with Earth's air is nothing short of a physical miracle. The moment a meteoroid survives its descent and touches the soil of our world, its name changes one final time. It becomes a meteorite. It is no longer just a phenomenon. It is a tangible piece of the elsewhere. It is a rock you can hold in your hand, a heavy, silent witness to the birth of the sun. The fusion crust, the signature of fire. If you were to find a meteorite in the wild, the first thing you would notice is its skin. Because the surface of the rock was heated to thousands of degrees for several seconds, the outer layer melted into a thin, dark, glassy rind. Scientists call this the fusion crust. It is the definitive signature of a cosmic traveler. Often charcoal black and sometimes covered in small, thumbprint-like indentations called regmaglypts, formed by the swirling vortices of superheated air. This crust is all that remains of the meteor's violent baptism. Inside this dark shell, however, the heart of the rock often remains frozen. Because stone is a poor conductor of heat, and the flight is so fast, the center of the meteorite can still be as cold as the deep space it left behind, even as its surface turns to liquid glass. The three great families of stone meteorites are not all the same. They come from different parts of the cosmic factory, and each type tells a different story about how our solar system was built. 1. Stony meteorites, the primordial archive. The most common type is the stony meteorite. Among these, the most scientifically precious are the chondrites. If you were to slice a chondrite open, you would see thousands of tiny, colorful spheres embedded in the rock, like jewels in a crown. These are chondrules. Chondrules are droplets of molten fire that solidified in the solar nebula before the Earth even existed. They are the original building blocks of the planets. In particular, the carbonaceous chondrites, like the famous Allende meteorite that fell in Mexico in 1969, are like a cosmic library. They contain water and organic molecules. When scientists analyzed the Murchison meteorite from Australia, they found something that changed our understanding of life forever: amino acids. These are the chemical components that build proteins and DNA. This discovery suggests that the ingredients for life were not produced by Earth alone, but were delivered here from the stars, carried on the backs of these stone messengers. 2. Iron meteorites, hearts of shattered worlds. Then there are the iron meteorites. These are heavy, dense, and composed almost entirely of iron and nickel. To understand where they come from, you have to imagine a world that was destroyed. Billions of years ago, there were protoplanets, massive asteroids that grew large enough to melt. In these molten worlds, heavy iron sank to the center to form a metallic core, just like the core of our Earth. When these worlds were later shattered by colossal collisions, their frozen metallic hearts were scattered into space. When you hold an iron meteorite, you are holding the core of a dead planet. If you polish a slice of this iron and etch it with acid, a stunning geometric pattern appears, the Widmanstätten patterns. These crystalline structures can only form if molten metal cools down at an incredibly slow rate, perhaps only a few degrees every million years. It is a pattern that cannot be faked in any laboratory on Earth. It is the slow-motion fingerprint of the deep cosmos. 3. Stony irons, the celestial stained glass. The rarest and most beautiful of all are the stony iron meteorites, specifically the pallasites. These come from the boundary layer of those ancient shattered worlds, the place where the rocky mantle met the iron core. A pallasite consists of a shimmering silver matrix of iron-nickel, embedded with translucent golden crystals of olivine, known as the gemstone peridot on Earth. When sliced thin and held to the light, a pallasite looks like a piece of celestial stained glass. They are the crown jewels of meteorite collections, representing a unique moment of cosmic balance. The age of everything. One of the most profound gifts meteorites have given us is the gift of time. For centuries, we could only guess the age of our world. But by using radioactive dating on the inclusions found in meteorites, the oldest solid materials in the solar system, scientists were finally able to put a number on our existence. We now know, thanks to these stones, that the solar system is exactly 4.567 billion years old. Every meteorite you see is a survivor from that first era. They have been drifting through the dark for 4.5 gigayears, unchanged, while Earth was being born, while oceans formed, and while life began its long, slow crawl toward the light. The weight of space. There is a unique sensation in holding a meteorite. You feel its weight. Iron meteorites are much heavier than any earthly rock of the same size. But you also feel its history. It is an object that has seen the birth of the sun. It has traveled through the vacuum between the stars. It has felt the fire of our atmosphere and the impact with our soil. And now it sits in the palm of your hand, a silent messenger from the great dark, finally at rest. This chapter takes us from the delicate streaks of light in the upper atmosphere down to the surface of the Earth itself. We are moving from the beauty of the falling star to the raw power of the impact. While our atmosphere is a formidable shield, it is not invincible. On very rare occasions, the universe sends a visitor too large, too fast, and too solid to be consumed by the air. When these giants strike, They don't just leave a stone behind, they leave a scar. These are the craters, the profound wounds that tell the story of Earth's violent past and the radical shifts in the history of life. The restless surface versus the eternal moon. When you look at the moon through a pair of binoculars, you see a world defined by violence. Its surface is a chaotic mosaic of craters, overlapping and layered, preserved in the airless silence for billions of years. The moon is a fossil of the solar system's history. Earth, however, looks different. To a distant observer, our planet appears smooth, green and blue. But this is an illusion of time and nature. Earth is just as much of a target as the moon. It has been struck millions of times. The difference is that Earth is restless. Between the shifting of tectonic plates, the relentless grind of glaciers, the erosion of wind and rain, and the persistent growth of forests, our planet is constantly healing itself, erasing the scars of cosmic impacts. Yet some wounds are so deep and so vast that even time cannot wash them away. Meteor crater, the pristine scar. The most famous of these scars is tucked away in the high desert of northern Arizona. Known simply as Meteor Crater or the Barringer Crater, it is a breathtaking sight. Roughly 1.2 kilometers wide and 170 meters deep, it looks like a giant bowl carved out of the earth. About 50,000 years ago, a chunk of iron nickel about the size of a modern office building slammed into the desert at a speed of 12 kilometers per second. The energy released was equivalent to 10 megatons of TNT, hundreds of times more powerful than an atomic bomb. In an instant, the rock and the ground beneath it vaporized, throwing up millions of tons of limestone and sandstone into the sky. If you stand on the rim of that crater today, you can feel the silence of the desert. It is hard to imagine that this massive void was created in a single, deafening second. It serves as a reminder that the falling stars we wish upon have a heavy terrestrial consequence when they are large enough. Chicxulub, the day the world burned. But Meteor Crater is a mere pinprick compared to the giant that sleeps beneath the Yucatan Peninsula in Mexico. This is the Chicxulub Crater, a wound 180 kilometers across, now buried under layers of sediment and the waters of the Gulf of Mexico. 66 million years ago, a mountain of rock 10 kilometers wide, an asteroid the size of Everest, pierced our atmosphere. It didn't just hit the ground, it punched through the Earth's crust. The impact was so violent that it ignited the atmosphere. Forests thousands of miles away burst into flames. Tsunamis hundreds of meters high raced across the oceans. This was the event that brought the age of the dinosaurs to a crashing, fiery end. But it wasn't just the impact that killed them. It was the impact winter that followed. The collision threw so much sulfur and dust into the stratosphere that it blocked the sun for years. The earth grew cold. The plants died. The food chain collapsed. It was a blank slate, a moment of total biological reset. The dual legacy, death and opportunity. There is a profound irony in the story of these impacts. While the Chicxulub asteroid brought annihilation to the dinosaurs, it also brought opportunity for us. In the shadows of the giants, our tiny, shrew-like mammal ancestors had been hiding for millions of years. When the dinosaurs vanished, a vast ecological vacuum was created. The world was suddenly empty, and the mammals stepped out into the light. Without that catastrophic falling star 66 million years ago, the history of evolution would have taken a completely different path. You and I might not be here today to look up at the stars. Impacts are the universe's way of turning the page of history. Vredefort, the ancient giant. To find the oldest and largest confirmed wound on Earth, we must travel to South Africa, to the Vredefort Dome. This impact happened over 2 billion years ago, when a bolide perhaps 15 kilometers wide struck the young Earth. The original crater was over 300 kilometers wide. Over eons, the edges have eroded away, leaving behind a massive circular structure that is visible even from space. This impact didn't just change the climate. It may have affected the very oxygen levels of our planet, influencing the early development of complex life. These craters are more than just holes in the ground. They are the punctuation marks in the long, epic sentence of Earth's life. The Chronicle of Silence. As you settle deeper into rest, consider the dual nature of the sky. It is a source of light, a place of beauty, and a canvas for our dreams. But it is also a place of immense prehistoric power. Every crater on Earth is a story of a traveler that finally ended its journey. They are silent testaments to the fact that we live on a planet that is part of a much larger, much more dynamic neighborhood. We are not isolated. We are participants in a cosmic exchange of matter and energy. The craters are the records of that exchange, the scars that show where the heavens and the earth have truly met. In our modern world, we have committed a quiet crime against ourselves. We have stolen the night. Most of us live under a constant orange shroud of artificial light, a phenomenon known as light pollution. We have traded the infinite depths of the cosmos for the convenience of the street lamp. To truly see a meteor, you must first become a rebel against the glow. You must seek out a dark sky sanctuary, a place where the horizon is clean and the stars feel close enough to touch. Astronomers use the Bortle scale to measure the darkness of the sky, ranging from Class 9, the center of a glowing city, to Class 1, a pristine, prehistoric darkness. When you find a Class 1 or 2 sky, the experience is transformative. You don't just see stars, you see the texture of the universe. You see the great rift of the Milky Way and the subtle, ghostly glow of nebulae. This is the stage where the falling stars perform. The biological transition, dark adaptation. Watching meteors is one of the few scientific activities that requires you to do absolutely nothing. In fact, the more you do, the less you see. The most important tool you have is not a telescope. It is your own biology. Your eyes are remarkable instruments, but they require time to shift into deep space mode. This process is called dark adaptation. When you first step outside, you are practically blind to the subtle details of the night. But slowly, over the course of 20 to 30 minutes, a chemical called rhodopsin, or visual purple, builds up in the rods of your retinas. This chemical is incredibly sensitive to light. It allows your vision to amplify the faint signals from space. However, this adaptation is fragile. One glance at your smartphone, with its harsh blue light, will instantly bleach the rhodopsin, and your 30-minute progress will be erased in a second. To watch the stars is to practice the discipline of the digital fast. The zen of the wait meteor watching is the ultimate exercise in patience. Unlike a movie or a video game, The universe does not operate on a schedule designed to keep you entertained. There may be long stretches of silence, 10, 15, even 20 minutes, where the sky remains perfectly still. In our culture of instant gratification, this can feel uncomfortable at first. But as the minutes pass, a shift occurs. You begin to notice the subtle rhythms of the night. You see the slow, majestic rotation of the constellations. You see the occasional satellite drifting like a silent spark. And then it happens. A sudden, silent streak of silver light cuts through the darkness. It is over in less than a second. But because you waited for it, because you sat in the stillness and earned that moment, the impact is profound. It is a reward for your presence. You have just witnessed a piece of cosmic history, an object that has traveled for millions of years, just to greet you in this one specific second. The equipment of the spirit. To watch a meteor shower, you need very little. In fact, telescopes and binoculars are your enemies here. They narrow your field of vision, making it more likely you'll miss a flash that occurs just outside the lens. The ideal setup is simple. A reclining chair or blanket. You want to look at the zenith, the point directly overhead, without straining your neck. Warmth. Even in the height of summer, the earth radiates heat into the cold sink of space. You must dress for a temperature 10 degrees colder than the forecast. Peripheral awareness. Astronomers use a technique called averted vision. Our eyes are actually more sensitive to light at the edges of our vision than in the center. By looking slightly away from where you expect a meteor, you may catch a fainter streak that your direct gaze would miss. The social and the solitary. There are two ways to experience this art. There is the shared wonder, gathering with friends or family, spreading out blankets and calling out, "There," whenever a meteor appears. It turns the cosmos into a community event, a shared story that links you to the people around you. But then, there is the solitary watch. Lying alone in the dark, you begin to feel the scale of the universe. You feel the earth beneath your back, a massive, spinning ball of rock, and you realize that you aren't looking up at the stars, but out into a bottomless abyss. The meteors become personal messages. In the silence, you find a peace that is hard to find anywhere else. Your breathing slows. Your heartbeat matches the rhythm of the night. You aren't just an observer of the universe. You are a part of it. Closing the circle. As you settle into your rest, think of the millions of people who have sat in the same darkness over the thousands of years of human history. They watched the same Perseids. They made the same wishes. They felt the same humbling peace. The art of the watch is a bridge across time. It reminds us that no matter how much our technology changes, our relationship with the night remains the same. We are children of the stars, looking back at our home. For centuries, astronomers assumed the solar system was a closed circuit. We believed that the debris we encountered, the comets, the asteroids, and the meteors, were all homegrown, born from the same cloud of gas and dust that formed our Earth. We looked at the fence of our sun's gravity and thought nothing could get in and nothing could get out. But in 2017, that illusion was shattered. A silent, dark object was detected moving through our system at a speed so high that the sun's gravity couldn't hold it. It wasn't orbiting our star. It was just passing through. This was Oumuamua, a name from the Hawaiian meaning a messenger from afar arriving first. The scout from the void, Oumuamua. Oumuamua was like nothing we had ever seen. It was elongated, perhaps 10 times longer than it was wide, shaped like a cosmic cigar or a flat disk. It didn't have a glowing tail like a comet, but as it moved away from the sun, it mysteriously accelerated, as if being pushed by an invisible hand. Astronomers debated its nature fiercely. Was it a shard of a shattered planet? A hydrogen iceberg? Or, as some more daring scientists suggested, a piece of ancient technology from a civilization long gone? While we may never know its true identity, Oumuamua taught us a profound lesson. The space between the stars is not empty. It is teeming with the lost children of other solar systems, fragments cast out during the violent births of alien worlds. The familiar stranger, Comet Borisov. Just 2 years later, a second visitor arrived. Comet 2b I/Borisov. Unlike the mysterious Oumuamua, Borisov looked exactly like a comet from our own system, complete with a beautiful glowing tail of gas and dust. When scientists analyzed its chemistry, they found it was remarkably similar to our own comets. This was a light bulb moment for humanity. It meant that the laws of chemistry and the recipes for building worlds are likely the same across the entire galaxy. Somewhere, thousands of light years away, another sun warmed a cloud of ice just like ours. Borisov was a piece of home from a place we will never visit. The interstellar meteor, a flash from the deep. This brings us to a breathtaking possibility. Could an interstellar traveler become a falling star? Most of the meteors we see hit our atmosphere at speeds between 11 and 70 kilometers per second. But an object coming from another star system would arrive with its own massive interstellar velocity. It would hit our atmosphere like a hammer, moving much faster than a local rock ever could. There is evidence that this has already happened. In 2014, a small fireball exploded over the Pacific Ocean near Papua New Guinea. When researchers later analyzed its speed and trajectory, they realized it was moving too fast to be from our solar system. If this is true, then for a few brief seconds, the people on those islands witnessed the fiery death of a traveler from another part of the Milky Way. A piece of an alien world turned into light in our sky. Panspermia, the cosmic hitchhikers. The existence of these interstellar travelers revives one of the most provocative theories in science, panspermia. If rocks can travel between stars, could life travel with them? We know that certain bacteria and organic molecules can survive the radiation and cold of space if they are buried deep inside a rock. If a meteorite from a life-bearing planet is ejected into space and eventually lands on a young, fertile world, it could act as a seed. Perhaps life didn't start on Earth. Perhaps it was delivered here by a falling star that began its journey around a sun that died billions of years ago. Every meteor we see might not just be a rock. It could be a container, a tiny lifeboat carrying the chemical blueprints of the galaxy. The infinite exchange. As you drift closer to sleep, consider the vastness of this exchange. The Milky Way is like a great ocean, and the stars are islands within it. The meteors are the spray from the waves, carrying bits of material from one island to the next. The falling star you see tonight might be a local pebble from a nearby comet, but it could also be a wanderer that has spent 100 million years crossing the dark abyss between the stars, just to end its journey as a silver flash in your field of vision. We are part of a galactic conversation, a constant flow of matter and history that knows no borders. Imagine you are standing in a silent, frost-covered field. Suddenly, a brilliant fireball, a bolide, tears across the sky, bright enough to turn the night into a fleeting day. And as you see the light, you hear it. A faint hiss, a crackle, or the sound of rustling silk. For hundreds of years, witnesses described these simultaneous sounds. But when they told scientists, they were met with skepticism and even ridicule. The math simply didn't add up. Most meteors occur at altitudes of 80 to 100 kilometers. Light travels at 300,000 kilometers per second, reaching your eyes instantly. Sound, however, is a laggard, traveling at a mere 340 meters per second. Mathematically, if a meteor makes a sound, you shouldn't hear it until 5 or 6 minutes after the flash. To hear it while you see it would be like hearing the thunder at the exact same microsecond you see the lightning. It defies the basic physics of our atmosphere. For a long time, these reports were dismissed as psychological illusions, a trick played by the brain's desire to pair a violent visual with a sound. The breakthrough, listening to radio waves. The mystery remained unsolved until the late 20th century, when researchers like Colin Key began to look not at acoustics, but at electromagnetism. When a large, fast-moving bolide slams into the atmosphere, it creates a massive, turbulent trail of plasma, gas so hot that its electrons are stripped away. This plasma trail acts like a giant moving transmitter. It generates very low-frequency VLF radio waves. These radio waves travel at the speed of light. They reach the ground at the exact same instant as the visual flash. But humans cannot hear radio waves. Or can we? The environment as a speaker. This is where the physics becomes truly fascinating. The VLF waves from the meteor don't enter your ears as sound waves. Instead, they interact with the objects around you. They can induce a tiny electric current in things like a wire fence, a patch of dry pine needles, a pair of glasses, or even a person's curly hair. These objects then vibrate very slightly, acting like the diaphragm of a primitive speaker. They turn the radio energy into actual sound waves right next to your head. This is known as electrophonic transduction. When a witness says they heard the meteor, they aren't hearing the meteor itself. They are hearing their own environment, the grass, their clothing, or their jewelry, responding to a pulse of cosmic energy. It is as if the universe is using the Earth as its own instrument to whisper its arrival. The thunder. After the flash, sonic booms. While the electrophonic hiss is simultaneous, there is another sound that is very real and very much delayed. The sonic boom. If a meteoroid is large enough to penetrate into the lower, denser layers of the atmosphere, it creates a shock wave. Because the object is moving many times faster than the speed of sound, it piles up the air in front of it. When that shockwave finally reaches the ground minutes later, it sounds like a deep, rolling boom or a sharp crack, similar to artillery fire. The Chelyabinsk meteor of 2013 provided the most dramatic modern example. Thousands of people saw the flash and went to their windows to see what happened. Minutes later, the sonic boom arrived, shattering the glass and injuring hundreds. It was a brutal reminder that the silent beauty of a falling star carries a physical punch that takes time to arrive. The psychology of the senses. The history of electrophonic sound is a lesson in the importance of listening to unscientific stories. For generations, the lived experience of ordinary people was dismissed because it didn't fit the existing models of physics. But by investigating the impossible, scientists discovered a whole new way that the earth and the heavens interact. It tells us that our senses are more interconnected than we realize. We don't just see the universe, we are bathed in its energy. A falling star isn't just a point of light in the distance. It is a broadcast, a surge of power that can reach down through the vacuum and the air to make the world around us hum with its presence. A silence deepened. As you lie in the quiet of your room, think about how much energy is moving through the silence. The world is full of invisible waves, signals from stars, pulses from the sun, and the radio whispers of passing meteors. Tonight the sky is likely silent. But if you were to see that rare, brilliant fireball, you would know that the hiss you might hear isn't your imagination. It is the sound of the cosmos touching the earth. It is the ultimate proof that we are never truly separate from the great dark above. In the 2nd century, the great astronomer Ptolemy proposed a beautiful, if unscientific, theory. He suggested that occasionally the gods, driven by curiosity or boredom, would peer down at the earth from the celestial spheres. To do so, they had to momentarily part the curtains of the firmament. In those brief moments, a bit of the heavenly fire would leak through the gap and fall toward our world. This, Ptolemy believed, was the falling star. But more importantly, he believed that because the gods were actively looking down at that very second, they were more likely to hear our prayers. This is perhaps the oldest origin of the tradition we still carry today. The idea that a falling star is an open window to the divine, a rare opportunity to send a wish directly to the architects of the universe, the guardians of secret knowledge. In Islamic tradition, the interpretation was more defensive. Ancient scholars and poets spoke of the shihab, the shooting stars. They were viewed as celestial weapons, fiery bolts hurled by angels to drive away inquisitive demons or jinns who attempted to eavesdrop on the councils of heaven. When you saw a streak of light, you weren't seeing a rock. You were witnessing a guardian protecting the boundaries of sacred knowledge. It was a sign that the order of the universe was being maintained, that the secrets of the future were being kept safe from those who would misuse them. The poetry of the transient. In the East, particularly in Japanese and Buddhist thought, the meteor was a profound teacher of the concept of mono-no-aware, the bittersweet awareness of impermanence. A falling star was the perfect metaphor for a human life. It appears suddenly, shines with incredible brilliance, and vanishes in an instant. It was not seen as a thing to be feared, but as a reminder to cherish the present moment. To see a meteor was to receive a lesson in beauty, that some things are precious precisely because they do not last. They are flowers of the sky, blooming and fading before the breath is even finished. The ancestors' campfires. For the Aboriginal peoples of Australia, the night sky was, and is, a complex map of the dream time. To some tribes, a meteor represented a spirit being traveling between the earth and the sky. In other traditions, meteors were seen as the campfires of ancestors who had finished their earthly journey and were now hunting in the great dark plains of the Milky Way. A falling star might be an ancestor moving their camp or throwing a spear. It was a deeply comforting belief, The sky wasn't a cold, empty void, but a place filled with the activity of family and history watching over the living. The tears of the martyr. In medieval Europe, the Perseid meteor shower of August became intertwined with the story of St. Lawrence. Having been martyred on a gridiron on August 10th, the heavy rain of meteors that followed each year was called the Tears of St. Lawrence. It was believed that these were the glowing embers of his sacrifice, transformed into eternal light and scattered across the sky to remind the faithful of his courage. Even today, in parts of Italy and Spain, the August meteors are greeted with a sense of religious reverence, a moment where history and the heavens collide. Omens of change. Not all cultures viewed the falling star with peace. To many, a sudden change in the unchanging heavens was a terrifying prospect. In ancient China, meticulous records were kept of every meteor, but they were often viewed as warnings. A meteor falling toward the east might predict a rebellion. A fireball that fragmented into pieces might symbolize a kingdom about to be divided. In European folklore, a falling star was often whispered to be the death of a great man or the arrival of war. There was an old belief that every person had a star in the sky, and when it fell, their time on earth was over. It made the cosmos feel deeply personal, if a bit frightening. A vast mirror reflecting the fates of kings and peasants alike. The universal wish. Despite these vastly different stories, one thing remains constant across almost every culture: the impulse to connect. Whether we see a meteor as a divine window, a demonic weapon, or an ancestor's spear, we cannot help but attach our own hopes to its flight. The act of wishing upon a star is one of the few truly global traditions. It is an acknowledgement that we are small and the universe is large, but that for a brief second we are part of the same light. As you drift towards sleep, remember that when you make a wish, you are joining a chorus of voices that has been whispering into the dark for thousands of years. You are never alone in your wonder. Imagine you are a small fragment of stone, no larger than a marble. For 4.5 billion years, your life has been defined by 3 things: cold, darkness, and silence. You have drifted in the vast, empty corridors of the solar system, a survivor of a collision that happened before the first mountain ever rose on Earth. You have watched the planets grow from dust to giants. You have orbited the sun millions of times, a ghost in the machine of the cosmos. In the vacuum, there is no wind to weather your edges, no rain to wash your surface. You are a pristine relic, a piece of frozen time. The call of the blue dot. From millions of miles away, you begin to feel a subtle change. A distant spark of blue and white begins to grow in your field of vision. It is the pale blue dot, as Carl Sagan famously called it. To you, it is not a home. It is a massive gravitational anchor. As you draw closer, the Earth's gravity begins to pull on you with increasing urgency. You aren't just drifting anymore. You are falling. The silence of space is still absolute, but your velocity is climbing, 10, 20, 40 kilometers per second. You are heading toward a collision that has been 4 billion years in the making. The first touch. At roughly 150 kilometers above the surface, the vacuum ends. You hit the very top of the atmosphere, the exosphere. It is so thin that a human would call it a vacuum. But to an object moving at 50,000 miles per hour, those few scattered molecules of gas feel like a physical blow. This is the moment of the first touch. You aren't glowing yet, but the friction is beginning to hum through your core. The cold of the void is being replaced by a creeping, localized heat. You are no longer a resident of space. You have become a visitor to Earth. The incandescence. As you descend into the mesosphere, the air thickens. The pressure in front of you becomes unbearable. The air cannot move out of your way fast enough, so it compresses into a cap of superheated plasma. Suddenly, you are no longer a dark stone. You are a spear of fire. Your surface, which has been frozen at nearly absolute zero for eons, instantly liquefies. The outer layers of your body begin to boil away, turning into a glowing trail of ionized gas that stretches for miles behind you. From the ground, someone looks up, gasps, and makes a wish. They see beauty. You are experiencing the most violent second of your existence. The final transformation. You are losing mass with every microsecond. The ablation process is relentless, stripping away your history, layer by layer. If you are small, this is where your story ends. You don't hit the ground. You become the ground. Your stone body is pulverized into microscopic dust, stardust, that will drift in the wind for weeks before finally settling onto a leaf, a roof, or the surface of an ocean. If you are large and strong, a heart of iron, you may feel the atmosphere trying to shatter you. The pressure builds until you reach the terminal flash, a final burst of light as your structure gives way. The pieces that remain slow down, the glowing plasma fades, and you fall through the lower clouds in dark flight, silent, heavy, and hot, one with the world. Whether you finish your journey as a grain of dust or a heavy meteorite, the result is the same. You are home. The traveler has reached its destination. Every breath we take on Earth contains a few atoms that were once like you, particles that spent billions of years in the dark before becoming part of our world. When we watch a falling star, we are watching the Earth exhale its light as it welcomes a new piece of the cosmos into its fold. We are witnessing the beautiful, fiery bridge between the infinite and the intimate. As the new year begins, while the world is still hushed by the winter cold, a mysterious display appears in the January sky, the quadrantid meteor shower. Unlike the Perseids, which linger for weeks, the quadrantids are famous for their razor-sharp precision. Their peak lasts only a few hours. If you miss that brief window, due to a few hours of sleep or a single bank of clouds, you miss the entire show for the year. The quadrantids are named after a constellation that no longer officially exists, Quadrans Muralis. But the mystery goes deeper than its name. For centuries, we didn't know where these meteors came from. It wasn't until 2003 that astronomers identified a rocky object, 2003 EH1, which may be the dead nucleus of a comet that shattered 500 years ago. These meteors often have a distinct blue tint, cold and sharp, echoing the winter air through which they fall. The Lyrids, the elders of the sky. In April, we encounter the Lyrids, the oldest recorded meteor shower in human history. Chinese astronomers documented these lights as far back as 687 BC, more than 2.5 millennia ago. The Lyrids are the debris of Comet Thatcher, an icy traveler that only visits the inner solar system once every 415 years. Even though the comet itself is currently far out in the dark, thousands of astronomical units away, the dust it left behind during its previous passes continues to greet us every spring. They are a reminder that the solar system has a very long memory. We are watching the residue of ancient celestial passages. The children of Halley, Eta Aquarids and Orionids. Twice a year, Earth passes through the debris of the most famous comet of all, 1P/Halley. Because of the way Halley's orbit intersects with ours, it gifts us two separate showers. In May, we see the Eta Aquarids, and in October, the Orionids. Halley's comet hasn't been near Earth since 1986 and won't return until 2061. Yet twice a year, we get to touch its legacy. The Orionids, in particular, are known for their speed, hitting our atmosphere at 66 kilometers per second. They are fast, energetic, and often leave persistent trains, ghostly trails of ionized gas that can hang in the air for several minutes, twisting and curling in the high-altitude winds like cosmic smoke. The boulders in the stream. The Taurids. Most meteor showers are harmless displays of dust. But there is one stream that astronomers watch with a different kind of intensity, the Taurid complex. Earth passes through this broad river of debris twice a year, in June and November. The Taurids are associated with comet Encke, but scientists believe Encke is just a fragment of a much larger, monstrous comet that broke apart 20,000 years ago. Unlike other streams, the Taurid complex contains more than just dust. It contains boulders. These are large, dark objects, some the size of cars or even houses, hidden within the stream. Some researchers believe that the Tunguska event of 1908, which flattened 2,000 square kilometers of Siberian forest, was caused by a fragment from the Taurid stream. It is a reminder that the beauty of the night sky sometimes masks a prehistoric power. Near-Earth objects, NEOs, and the Shield of Science meteors are the visible daily reminder that space is full of debris and that Earth is, essentially, a target. This has given rise to the field of planetary defense. Today, telescopes around the world and in orbit, like the NEOWISE mission, scan the darkness every night for near-Earth objects. We are no longer helpless observers like our ancestors. In 2022, NASA's DART mission successfully crashed a spacecraft into a small asteroid, proving that if we find a dangerous object early enough, we have the technology to nudge its orbit and save our world. The falling stars of the past were omens of doom. The falling stars of the future may be the tests that prove our species' survival. The Great Inventory. We have now mapped over 30,000 near-Earth asteroids. We know where the big ones are, and none of them pose a threat for at least the next century. This knowledge allows us to look at the night sky, not with fear, but with a renewed sense of wonder. The meteors we see tonight are the small fry, the harmless grains of sand that provide us with beauty without the threat of catastrophe. They are the safe, glowing reminders of a solar system that is still very much alive. As we move from the sky to the ground, we find a dedicated group of humans who turn watching into hunting. Finding a meteorite is one of the most difficult challenges on Earth. Most of our planet is covered by water, forests or grass, where a dark rock from space easily disappears. But there are two places where the Earth keeps its cosmic secrets in plain sight: Antarctica and the hot deserts. Antarctica is the world's greatest meteorite graveyard. For millions of years, meteorites have fallen onto the vast ice sheets. As the glaciers move toward the coast, they encounter mountain ranges that act like a dam. The ice stalls and is gradually scoured away by fierce winds, leaving behind the heavy rocks. On the brilliant, blinding white of the Antarctic ice, a black meteorite stands out like a beacon. Since 1976, expeditions have recovered tens of thousands of specimens here, including pieces of the Moon and Mars that were blasted off their homeworlds by ancient impacts. The rarity of the prize. To understand the obsession of the meteorite hunter, you must first understand the odds. Every day, Earth is pelted with debris, but most of it vanishes into the oceans or the dense, unreachable canopy of the rainforests. To find a meteorite is to find a needle in a planetary haystack. These stones are rarer than gold, rarer than diamonds, and carry a history that no gemstone on Earth can match. For the professional hunter, this is not just a hobby. It is a high-stakes adventure. They don't just look for rocks. They look for the anomalies. They look for the fusion crust, that thin charcoal black rind that tells of a journey through atmospheric fire. They look for regmaglypts, the peculiar indentations that look like thumbprints in clay, carved by the turbulent fingers of superheated air. And they carry magnets, for most meteorites are rich in extraterrestrial iron, clicking onto a searcher's tool with a satisfying metallic snap that signals a potential discovery. Antarctica, the natural concentrator. The most prestigious hunting ground is the frozen wilderness of Antarctica. It is a place of brutal beauty and absolute preservation. Here, the meteorites don't just land, they are archived. When a stone falls on the Antarctic ice sheet, it is quickly buried by snow and becomes part of the moving glacier. Over thousands of years, these glaciers grind against mountain ranges like the Transantarctic Mountains. The wind, a relentless and frigid force, scours away the top layers of ice in a process called sublimation, exposing the rocks that have been trapped for millennia. In these blue ice fields, a single dark stone can be spotted from miles away. Since the mid-1970s, international teams have recovered over 48,000 specimens from the ice. These stones are pristine. Because they have been kept in a natural deep freeze, their delicate organic chemistry remains exactly as it was when they were floating in space. The Sahara, the NWA market. In the burning heat of the Sahara Desert, a different kind of industry has emerged. For the nomadic tribes of North Africa, a falling star is a source of life-changing wealth. These searchers systematically scout the vast, flat plains of the desert, where dark stones shouldn't exist. This has created the NWA Northwest Africa classification system. Thousands of meteorites are sold each year to collectors and scientists worldwide. While some worry about the commercialization of these specimens, others argue that without this gold rush, thousands of scientifically vital stones would simply be swallowed by the shifting dunes. It is a complex world where the ancient traditions of the desert meet the cutting-edge needs of the laboratory, the ethics of the extrasolar. The market for these stones is staggering. A piece of a witnessed fall, a meteorite that was seen as a fireball and recovered immediately, it's the ultimate prize. Specimens from the Chelyabinsk event or the Allende Fall are traded like fine art. But the most valuable are the planetary meteorites. We have found stones on Earth that we know, through chemical fingerprinting, came from Mars or the Moon. blasted off their surfaces by massive impacts millions of years ago, they drifted through space before finally landing here. Holding a piece of Mars in the palm of your hand is a profound experience, but it comes with a question. Should these treasures belong to the person who found them, or do they belong to the heritage of all humanity? It is a debate that continues in museums and auction houses around the globe. The weaving of worlds. As we draw our long journey to a close, it is time to look at the reflection in the mirror. We often speak of the heavens and the earth as if they are two separate worlds, divided by a great invisible wall. No falling stars prove that this wall is a myth. Every atom in your body, the iron in your blood, the calcium in your bones, the carbon in your very cells, was once forged in the heart of a dying star. These meteors we have discussed are not alien to us. They are our kin. We are made of the same primordial stuff that built the asteroids and the comets. When you see a meteor streak across the sky, you aren't just watching a rock burn. You are watching a cosmic reunion. You are watching the universe recycle its history. The psychology of the sky. There is a reason why we feel a sense of peace when we look at the stars. In the presence of the infinite, our small daily anxieties begin to lose their grip. The falling star is a reminder of the big picture. If a fragment of stone can survive 4 billion years of cold and a second of fire just to land in a quiet field, then perhaps we too can survive our own brief atmospheric moments of life. The sky offers us a perspective that the earth cannot. It teaches us that change is the only constant and that there is a profound, silent order behind what looks like chaos. The gentle fade. Imagine the sky tonight. Even if you cannot see it, the rain of dust is continuing. Tens of thousands of microscopic travelers are entering the air above you right now, settling slowly like invisible snow. The earth is breathing in the cosmos, and the cosmos is exhaling its light. Let the rhythm of your breathing match this celestial flow, in and out. The slow, steady pulse of a planet moving through the dark. You are safe. You are part of a system that has been functioning perfectly for eons. The same gravity that pulls the meteor to the earth is the same force that holds you gently in your bed. The story of the falling star is a story of hope. It tells us that even in the deepest dark, there is light. It tells us that even the smallest grain can leave a lasting impression. And it tells us that we are never truly alone, for we are surrounded by a cloud of witnesses, the remnants of the birth of our world, still circling us, still reaching out to us. If you feel your eyelids growing heavy, allow the grand story of life on earth to wrap around you gently and guide you into calm. Don't forget to subscribe to listen to more of our bedtime stories. Close your eyes, take a deep breath, and slowly drift into sleep, into silence, into the boundless, timeless current where all life intertwines. Wishing you a quiet, comforting night.